In the last decade, AI has taken the world by storm. Everyone agrees that AI will change our lives, but out of the 24 million programmers across the globe, just 300,000 are proficient in AI. So why isn't this number bigger? After all, the models are publicly available. It's easier than ever for an engineer to deploy pre-trained networks like ResNet and VGG. Today, the real obstacle is data. Every programmer knows the age-old saying, garbage in, garbage out. The largest bottleneck in model performance is the quantity and quality of data, and even seasoned data scientists can spend up to 80% of their time cleaning, adjusting, and massaging data to get the best results from their models. Choosing from numerous strategies like image augmentation, dimensionality reduction, and object detection can easily become overwhelming for a new data scientist.
That's why we made PyTuna, a preprocessing wizard that takes in any image dataset and guides programmers through the best practices for preprocessing their data. Under the hood, PyTuna uses a 3D convolutional neural network with several fully connected layers trained on image datasets from a corpus of the most cited research papers and top scoring Kaggle submissions. PyTuna samples 400 images from each dataset and creates 40 stacks of 10 images that are then associated with a 12-element label vector where each element represents a preprocessing step used. When the user uploads a dataset, PyTuna takes a random sample of 50 images and recommends an appropriate combination of preprocessing techniques such as image augmentation, resizing, and normalization. The user can then go through each suggestion and select if they want to apply the preprocessing step to their dataset. PyTuna will then automatically apply the preprocessing step to the dataset and save a processed copy of the data that is ready to be used in a neural network.
For example, say I'm a birdwatching enthusiast with a technical background but no particular specialization in AI. I have hundreds of pictures of birds I've amassed from my 5 years of birdwatching, all hand-labeled by me and my friends. I pull up my trusty PyTorch compiler and load my data into ResNet, hopeful to make something that can immediately identify my avian companions. But validation accuracy comes back, 25%. Before PyTuna, I might give up and call it a day, resigned to spend hours after every birdwatching session personally identifying birds. But with PyTuna, I can load my data into the wizard, which guides me through and automates the pre-processing for me. I suspected that the sunset caused a slight red tint in some images, leading the model to learn a nonsensical rule about lighting. Luckily, PyTuna suggested normalizing each of the RGB channels, which mitigated the effect. Now my accuracy is 90%, much more respectable.
Now, let's run through a short demo of PyTuna. Let me fire up my demo Jupyter notebook. The cool thing about PyTuna is that it integrates right into my existing ML workflow, so I just import the module, and the wizard is ready to go. I'm working on a dataset of CAPTCHA images. In my case, I'll use the model which comes pre-packaged with PyTuna to predict which preprocessing steps I should use. I'll load it to my GPU since it has enough RAM. Suppose I'm planning on applying transfer learning, and I'll be using a pre-trained AlexNet. PyTuna is smart enough to know its input dimensions, and automatically resizes my images. Now, PyTuna suggests that I should zero center my images, and I agree, so I'll just press enter. Same thing with augmenting my data. Note that even though PyTuna suggests not to increase the contrast of my images, I still can do that if I choose to. Now, PyTuna doesn't suggest histogram equalizing my images, and I agree, so I'll skip that step. PyTuna suggests a Gaussian blur, and I agree, so I'll use that step. And it looks like that I agree with PyTuna for the rest of the steps. Now that I have my pre-processed dataset, I have the option to pickle it and store it to disk to use for future projects. In my case, I'll use the default output directory. And looks like it's done. And sure enough, the directory containing my pre-processed dataset has now appeared. Finally, I can verify the length and dimensions of my preprocessed dataset, which is ready to be fed into my AlexNet model. And one last thing, PyTuna offers the exact same functionality straight from the command line.
And that's the use case for PyTuna, to help people just getting into machine learning overcome this difficult to impossible hurdle and get to the cool stuff faster. And PyTuna is just the beginning. We're working toward a future where anyone can use PyTorch to tap into the potential of AI.